Welcome back again. Now, today we'll be moving on to the next chapter. That is, in your textbooks and all, the chapter is called permutations and combinations. But for ease, for to make it easier, and also to make a proper name, the title name should always be kind of short. So, okay, not because of that, but it make it to, I wanted to give a different name to it, so I'm giving the chapter another name, and that is called arrangements. You will come to know why I call that. But today, we will not be going on to see arrangements. Today we'll discuss, or I will, okay, not discuss, I will tell you about another tool, about a function that we need to study arrangements, or to solve questions in arrangements. So this function is called factorial, and the factorial is also just another function like any normal function. Okay, so you have studied about different functions. You have studied about linear function. Linear function is y is equal to mx plus c. Quadratic functions, y is equal to x square plus blah blah blah. And you have studied about trigonometric functions where y is equal to sine x, and you have studied about exponential function, that is y is equal to e to the power x. Now these are all things that you already studied, but this is another function that is called factorial. And factorial is basically a French, it comes from French. Okay, the word is from French language, and of course it is factorial. Factor means, what factors are. The things that factors are the things that make up a product. For example, if I say 2 into 5 is 10, 10 is a product, and 2 and 5 are factors. Now, what is factorial function? When I say factorial, it means continuous multiplication of natural numbers in decreasing order. So you take a natural number and you write all the natural numbers from that natural number to the, just keep decreasing the numbers. For example, if I say 3 factorial, write 3, then write the next decreasing number 2, then write the next decreasing number 1. So, and then just multiply them, 3 into 2 into 1, continuously multiply them. That is factorial. Now I'll give an example. Now it is denoted by the symbol exclamation mark. So this is the symbol for factorial. Okay, now for example, 5 factorial is equal to 5 into 4 into 3 into 2 into 1. Why didn't I go to 0? Because it is not a natural number. Okay, so factorials are continuous multiplication of natural numbers. Then 8 factorial is 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. You get it? See how long it is. You also see that as the numbers grow bigger, it becomes difficult to write all the numbers in decreasing order, right? So we have a better way to write. Now you might also be thinking, sir, why these unnecessary functions? I know this sounds very unnecessary right now. This sounds very stupid kind of right now. Why just keep multiplying numbers like this? But there is a reason. There's a very good reason why we need factorial, and you'll come to know when we study about arrangements. We really need the factorial function that time, and yeah, we'll come to that. So yeah, let us but one thing, let me also tell you. I told you this is a continuous multiplication of natural numbers. See, factorials can be extended. This is just for information. You won't study this in your school time. Till you passed in your school days, you won't study this. But if you take higher courses of maths, you will come to study this. Unless then you won't learn about this. But let me just tell you for your information. We always come to study about factorial as multiplication of natural numbers, that means positive integers without 0, but it can be extended to negative numbers, and it can even take fractions. For example, factorial of 5.2, factorial of 5.3. but you won't study this in school, and because it is more than because you have enough to study. Now, but let me just let you for information that factorial can be extended to you know negative numbers. And when you say negative numbers, it will include complex numbers also, it will include imaginary I and all. But anyways, that is called gamma function, and you won't study this, just for information. For now, just remember that factorials are continuous multiplication of natural numbers in decreasing order. Now there are different ways to write it. One way of writing 5 factorial is 5 into 4 into 3 into 2 into 1, right? Now if you look at 4 factorial, you will see that it is 4 into 3 into 2 into 1. Now if you look at both 5 factorial and 4 factorial, you see that 4 factorial is included in 5 factorial. That is 5 factorial, this is the same part, 4 into 3 into 2 into 1. So I can also write this 5 factorial as 5 factorial into 5 into 4 factorial. You see, this is a very simpler way of writing it. Instead of going and writing all the numbers to 1, I can just write it as 5 into 4 factorial. So if I have 152 factorial, instead of writing 152 into 151 into 150 into 149 into 148, instead of going like that, I can just write it as 152 factorial is equal to 152 into 151 factorial. End of story. Now so this way of writing is called recursive function. I'll tell you that later. So let us write this in a general format. N factorial is equal to n into n minus 1 into n minus 2 into n minus 3 into, at last it will come into 2 into 1. But this is a better way to write it, and as I told you, it is n factorial is equal to n into n minus 1 factorial. Rest of the terms will become under n minus 1. We'll leave the burden to n minus 1. So n factorial is equal to n into n minus 1 factorial. And this type of writing is called recursive function. It's a recursive function. That means the answer of a factorial function is itself another factorial function. See, usually we don't write the question itself as the answer, right? The answer is something that defines it. But here, the answer of n factorial itself is another factorial. So that is why it is called repeating function. Recursive means it's another word. Recursive means repeating itself. So it is a repeating function. Anyways, so this is about what factorial is. Now, before I stop the class, I need to tell something about 0 factorial, one important factorial. Why is it important? I don't know as of now, but it comes up in the problems, and therefore we need to know what is 0 factorial. Because what is 1? According to the definition of factorial, n factorial is equal to n into n minus 1 factorial. So what about 1 factorial? 1 factorial is 1 into 0 factorial. And if we do not know 0 factorial, how will we solve it? So let us go and find what is 0 factorial. But before that, I need to clear something that you studied in your 9th standard. I think you studied this in your 9th standard. See, in your 9th you studied that x to the power 0 is equal to 1. That is anything to the power 0 is equal to 1. But how do you know it? Did you prove it? How do we know? Can we see it with our eyes? X square is x into x. I can always see it. If I keep something, I can if I can see that x square, x cube is equal to x into x2 cube. If someone tells me and comes and tells me 2 cube is 8, I can verify it. 2 cube is 2 into 2 into 2. That means 4 into 2 is equal to 8. But how do I verify this? X to the power 0 is equal to 1. So we can look at a series of patterns and understand that. That is, look at this. X to the power 4 is x into x into x into x. If I divide x to the power 4 divide by x, if I divide x to the power 4 by x, I will get x to the power 3. That means if I take one x off, if I divide x to the power 4, I get x to the power 3. If I divide x to the power 3 divided by x, so x to the power 3 divided by x will give me x to the power 2. X to the power 2 divided by x will give me x to the power 1. And x to the power 1 divided by x will give me x to the power 0. So what is x to the power 1 divided by x? It is x by x, which is 1. So you get it. That is one way that we can understand why x to the power 0 is equal to 1. Now, let us use the same method in understanding what 0 factorial is. 5 factorial is equal to 5 into 4 into 3 into 2 into 1. 4 factorial is 5 factorial divided by 5, right? So 5 factorial divided by 5, I get 4 factorial. 4 factorial divided by 4, I get 3 factorial. 3 factorial divided by 3, I get 2 factorial. And 2 factorial divided by 2, I get 1 factorial. And 1 factorial divided by 1, I get 0 factorial. So what is 0 factorial? 1 factorial divided by 1. 1 by 1 is equal to 1. So you get it. So thus we can say that 0 factorial is equal to 1. Now you see that Max, you see this amazing thing in that pattern, a pattern follows, and that is one interesting thing I would say that we can see in that we can see here, that there's a definite pattern that is being followed. And it is not that suddenly someone came and said, oh, 0 factorial, we will just call it 2, we'll just call it 3. No, there's a reason why 0 factorial is equal to 1. According to definition, we cannot say, because we cannot say 0 factorial is equal to 0 into anything, because factorial is basically for natural numbers and 0 is not a natural number. But we can understand what it is by just following this pattern. I hope you are able to understand. So anyways, so this is what we have to study today, and that is about factorial. Now the rest of the thing we will study in the next class. And so so make sure that you understand factorial, the function factorial, really well, because we need to use factorials to understand the things that will be taught in the next class. Thank you for listening. Bye bye.